All right. Welcome everyone that is here. I think we are now live. I am really excited for this particular webinar. This is an area that I'm really passionate about. I think AI has something incredible to offer, and this is very timely and relevant to the world that we're in today. So this is Breaking Language Barriers, AI-powered language translation and reasoning, specifically for insights and guidance for manufacturers. So for all of you joining live, thank you. For those of you that are watching this later, thank you as well. So manufacturing is at a crossroads, growth and disruption. Today, we're doing this live, is March 6th. And, skipping ahead on the slide a bit, but just yesterday, I guess a couple of days ago in the US, there was this announcement of significant tariffs. Just yesterday, the automotive industry got a 1-month reprieve. We're in the midst of a really unique, challenging time, also with a lot of opportunities for manufacturers. So in the United States, where I sit, there is ever increasing demand. $2.93 trillion is the US manufacturing GDP output, $236 billion being spent on new construction. And the US is not the only country in the world that's investing significantly in its domestic, maybe even fully local or regional manufacturing, where there's increasing desire to have things built close to where consumers are doing them and keep manufacturing jobs, manufacturing work in the countries and the regions that people live in. Why is this happening? Well, one is these geopolitical disruptions. So just recent examples, there was the Suez Canal, Red Sea Houthi attack. It's like pirates are a real thing again in this world, and it doubled shipping times and costs. So it's no longer as easy to have a factory in one place in the world and just ship it all over the world and assume that nothing will happen to these cargo ships. There was the drought in the Panama Canal. There's rising costs and logistics delays. It's not too many years ago that we were still exiting COVID, where this very interconnected world, for example, of just-in-time manufacturing and automotive, was totally shocked by not being able to get the components that they were after. And so, as mentioned, where I sit here in the United States, we're just days after this tariff shock where there's now a 25% tariff on our nearest neighbors, Canada and Mexico, which before automotive was pulled out, the National Association of Manufacturing here in the U.S., NAM, estimated that this would cost U.S. manufacturing $144 billion. So that's, where's that cost coming from? Well, the reality is that manufacturers' supply chain bases are still spread across the world. They've been increasingly regionalizing and localizing, but they are not there today. We're in this shift of a kind of truly globalized manufacturing to a regional manufacturing. There was another 10% tariff on Chinese imports. All that's happening is relevant because it is focusing the attention on the growing talent and workforce gap that's happening in factories. This is really the signal from the noise is this part. So again, starting with the United States, we have 428,000 jobs open for manufacturing, and 65%, the vast majority of manufacturers report that attracting and retaining talent is not just one of their top challenges, it is the primary business challenge to run their whole company. That's crazy. It shouldn't be that way. Like there should be other challenges that how do I just design the best new, product, right? How do I keep my machines up or something like that? But no, the by far biggest challenge is attracting and retaining talent. And that results in 3.8 million manufacturing jobs needed by 2024. And when you break that down, very interestingly, if you look into the fine text of the slide, you see 760,000 for growth, 230,000 from legislative actions. So these big things happening in the world are accelerating this in the US context, but the biggest number by far, 2.8 million from retirement. And this is something that's happening all over the world, not just in the US context, is that this geopolitics is increasing the need for regional and local factories to hire even more talent. And at the same time, this is coming in the midst of this even greater challenge in the factory, which is the aging workforce, this growing expert labor crisis. So across the whole world, there's 10 million factories. They spend $100 billion on software. It sounds like a lot in total, but it's nothing compared to $4 trillion on labor. People run factories much more than software or machines run factories. And these people, these critical people, need 5 to 10 plus years of experience to do what they need to do. They need to learn, how do I maintain a machine? What are the key steps? Maybe they're a process engineer or industrial engineer. How do I balance these lines and lay them out? A planner. How do I do the planning in the factory, right? These different jobs require significant expertise, and expertise that you usually get on the job. Well, 10 years ago, the average tenures in most factories was 15 plus years. So this wasn't a challenge. This is how it worked. And you became highly skilled, and you did the work. But now average tenures are dropping precipitously, 5 years and dropping. And again, back to the last slide, part of this is the geopolitics, new factories in new places with brand new people. But the biggest part of it is, while that's happening, we have our experts retiring, and we're replacing it with a different kind of workforce that only expects to work in a given factory for a fewer number of years. The end result is $300 billion expert labor crisis that is rapidly growing. So in manufacturing, we know that the constant call is, how do we do more with less? Every single year, how do we, create more output, even though we have the same team, right? How do we waste less in the factory, right? And now, how do you do more with less expertise? That is particularly challenging in manufacturing. And some of the world's top manufacturers have realized that there's something really powerful they can do in sharing expert knowledge. And a great quote from the CEO of Flex, Ravati Vaiti, is, as she says about her company, excellence anywhere is excellence everywhere. How do you make that true? How do you make it possible that excellence anywhere in your footprint, in any given factory, could become excellence everywhere in this new world? So that's what we're going to talk about today. We've got a really exciting demo coming up and a case study at the end. So to get us into the demo and the context for what we're going to do here, let's talk a little bit about the specific types of skills that are critical. So every factory relies on key roles to maintain efficiency, solve problems, ensure quality. These experts hold critical knowledge, and it's often siloed. In other words, it's kept to themselves, it's kept to their own discipline. And why? Why is it siloed? Even within a factory, language barriers can play a role, because there's often international folks speaking different languages, even in a different country. It's certainly true in the United States here. Across factories, language plays a big role. We're going to talk about that today. Of course, it's not only that, it's turnover, again, that the retiring wave, lack of structured documentation. So we've got production managers, process engineers, manufacturing engineers, test engineers, equipment technicians, the people that run the machines themselves. How do I do that? Industrial engineers. How do I balance the line? How do I create the best throughput? Maintenance engineers. What are the steps to fix this given problem on this machine, on this nozzle, on this CNC, this spindle, right? Manufacturing planners. How do I plan in this factory? There's a lot of knowledge that gets built up. And in any given factory, at any given point, it is increasingly common that some of these bubbles are missing. It's not that every factory in the world lacks, planning expertise only. Some factories lack planning. Some factories lack process engineering deep expertise. Some lack maintenance engineering deep expertise. And so somehow across your enterprise, you have to figure out ways to assist and co-pilot these people in a new way. And this is where AI-powered knowledge transfer comes in. So when we think about what experts do, they absolutely use their hands. They're in the factory themselves. They figure something out, and maybe they use their hands to literally fix the machine as a maintenance engineer, or to program or set up a new plan and communicate it to people. But it's not their hands that are magical, right? It's them, their wisdom, their knowledge, their experience, their brains, right? And what are they doing? They're root causing what really is the problem here. Why is this machine broken, right? Why is the process not working the way it is? And they give guidance, often to themselves, but they give guidance to the new people as they're training them. And this is exactly where AI comes in. It enables global knowledge sharing by translating expert insights across languages. So within a factory and even across factories worldwide, we can collaborate in a totally new way. Like this picture here, a maintenance engineer in Malaysia and a new person in the United States or elsewhere, receiving knowledge that lets them be a better maintenance engineer faster. All right. So let me see if I can get my colleague Joe here into the meeting. Joe, how are you doing?
Good. How's it going?
It's going very well. We're excited to welcome you in here. We would like a demo now of this multilingual knowledge sharing and how this works. I guess, yeah, talk us through first, just to set the basis, like how do AI systems like Arches, how do they work at all to give somebody, to try to root cause and give guidance? And then where does language and knowledge sharing come into this?
So, for Arch specifically, our AI system is doing a couple of different things. It's monitoring what we call the voice of the machine. So, this is something that a lot of companies do, right? You're monitoring all the data, all the machine data, all the parametric data that you can find in all these different data sets, looking for anomalies, looking for trends, trying to tack things together to say, hey, this has happened 5 times before, this has happened 10 times before, maybe you should look at it. What makes Arch really unique, in my opinion, is that we also look at something called the voice of the operator. So there's only so much that the machine data can tell you about the entire situation or the entire context of what happens on a shop floor. Really, the expert isn't the machine. The machine can only see what the machine is doing. The expert is the operator or the process engineer or the maintenance technician who's seeing everything as it happens on that shop floor. So what Arch does is, yes, it monitors for all this machine data. We have models and algorithms that connect trends together, but we also offer really seamless interfaces to capture the knowledge of that person who's in the situation, seeing it all in a total 360 perspective, getting their comments, whether it's straight from their voice or their thoughts straight into notes, things we call playbooks. So this is what you should do when this happens. This is what you should do when that happens, trying to create interfaces that allow them to log that information so we can look at both. It's not just one or the other. We're trying to get that full picture. And so we use AI to transcribe languages. We use AI to generate summaries based off of that data that we've assembled so we can summarize all the things that have happened from the machine and also from the operator, and then
Yeah,
represent it to the next person in line who might not have that knowledge that was tucked away in someone's brain, that little pocket back there, like, oh, I've seen this before, I've done this before, let me tell the system how it's done. That way the next person can benefit off the top of it.
absolutely. Well said. Let's see what that looks like. Can you pull
Great.
us up a demo here?
Yeah, please. I think Jesse's gonna help me out. So, okay.
Hello, my
Um,
name's Joe
if
Morton.
you can mute it, Jesse. I'm gonna run through a demo that I've done quite a few times. So just mute it and let it play. This is gonna be a demo on capturing and transferring shop floor knowledge, specifically in a situation where there's perhaps a
I'm a
language
product
barrier
manager at Arch
across
Systems,
two
and
different.
I'm
Oh, there you go. Okay, where there's a language barrier across two different users. So if we jump ahead just a little bit, I'll paint the picture for you, paint the scene. Here, let's imagine here I am a junior process engineer in, call it Detroit, United States. And I'm monitoring my line. Maybe I'm a couple months old, monitoring, not a couple months old, a couple months new to the job. I'm monitoring my line and I have an issue pop up. Luckily, Arch's Action Manager
You
tool
do you
puts
do
that.
look that young and fresh, Joe. You could be a couple of them.
I appreciate it. I try. Uh, an alert pops up from Action Manager, Arch's alerting and ticketing system. It's telling me that there's a profile, an attrition profile, a threshold has been violated. So I'm getting a ticket on that. And then Action Manager is giving me a summary of what it knows happened. So this, again, this is a generative AI piece of Arch. It's assembling the data and then summarizing it for the user. And it's telling me I have high attrition on a machine, NXT2-4. It's significantly above other machines. And also I have a total attrition on this line that's outside of the threshold that I've set for this alert. So it's telling me this is what's going on. Specifically, this machine is what's causing an issue. And then if you go down further, it's saying not just the machine, but actually nozzle 6 has the highest amount of mispicks. And that's probably you should look at. You can see it's giving me a probable root cause. So the feeder nozzle issue on NXT2-4 at nozzle 6. So immediately I know, okay, there's an alert, something's going on. I need to look at nozzle 6. The system's telling me there's something happening here. So then not only does it give me a summary, but if I look down, I can see next steps. So I can see, okay, step 1, I'm going to inspect and calibrate this pick and place machine. Step two, I'll check for wear on that specific nozzle. And then finally, I'll do a little feeder calibration, maybe do some alignment tests, and run some final tests on that step four to try and get the machine running. So the system is telling me all this based off of dashboards that are monitoring all of these different things that it has access to. And then me as engineer, I'll go back in, I'll try, here I am on the line, trying to get this thing running again. I probably have to take the line down for a little bit, have some downtime. Then I'll come back into my ticket, I'll click resolve and say, okay, I went through all these steps, followed everything I could. Unsure if it really worked. Maybe it did. I ran some tests and changed a few calibrations, but we'll see. Let's hope. So if I look at this, I'm getting a summary generated by the system based off of everything the system knows about the situation. So it's looking, again, taking screenshots of dashboards, maybe dashboards that Arch creates, or maybe they're internal dashboards for an organization. It's grabbing all of the contextual machine data that it possibly can to point the user directly at the issue where the person needs to look. So as a junior process engineer, you can only hope
I
that
know
it
you're about
works.
to go beyond this, Joe, but
Yeah,
yeah, I mean, this is amazing. Here, you said, okay, we also want to bring in the voice of the operator, but you've fused a lot of different data sources here from the machines and the dashboards to figure out what you think is the root cause and given guidance right away, right?
correct. So it's giving you rather than prior to this, if I didn't have this system, I'd have to open up three different dashboards, look at some different panels. If you can pause it for a second, Jesse, look at some different panels and see, try and look through all these different graphs to find which machine it's on, what nozzle maybe, and then take a guess. Here, I skip that whole process. I just look right at what's going on, what was the main issue, and then get right into how do I fix it.
Awesome. Yeah, please keep
Great.
going.
Yeah. So you can keep it going there, Jesse. Um, let's now shift. Let's say we're a couple days later and we're also across the globe. We're at a different line. Now we're in Tel Aviv, and here we're watching another user. Let's say it's a crack ace maintenance technician, or call it a process engineer, someone who's on the floor diagnosing an issue. This is Shahar. Shahar is in Tel Aviv, and he is facing a downtime on a line, and he's trying to fix that downtime, get the line running again. So he's interacting with the screen here. This screen is probably Arch's React tool. React is our downtime monitoring and labeling tool. And Shahar is tasked with get this line up and running as quick as possible. Now, remember, Shahar, expert. He's an ace. He's done it. He's seen it before. If you go back just a beat, yeah. So this is probably the screen that Shahar is looking at. This is React's downtime monitoring screen. So you can see there's a few different downtimes that have been logged, all with different times, at different times, and based off of different things. Here at the bottom, you see a downtime card called placement issues. So this is specifically the one that we're interested in. You can see there at the bottom of that card, insights, comments, photos. What we're interested to know is how did Shahar diagnose this downtime? And did he leave us any gems for us to pick up on? So if you play, we should maybe get us, I think the timestamp's at 550 there. I see. And we'll
Leave a
click
comment.
in. You can see
Let's
here.
see what he said.
Yeah. We'll listen to what Shahar left as a comment.
בעיית נפל רכיבים, מקור הבעיה התגלה במכונה 4, ראש 1, בנוזל מספר 8, כפתרון זמני ביטלתי השמת רכיבים לנוזל הזה, ועכשיו אגש לבדוק אם יש לנו נוזל חלופי זמין במלאי.
Okay,
Okay,
great.
so
Do you want to pause, Jesse? And then you can mute the video again. So Shahar left us a comment. He left us a comment in Hebrew, obviously his native language. I don't speak Hebrew, but luckily for me, Arch's system is able to both transcribe and translate the comment that Shahar left. So if you look at the bottom, you can see the transcription says there's an issue in component placement. The problem was traced to machine 4, looks like nozzle 8, and he has a temporary fix. He disabled the component placement for that nozzle. So now he's going to go check if he gets if there's a replacement in stock. So our diagnosed it. He was able to quickly get the line back up and running to avoid a major downtime just by disabling that nozzle. And now he's going to go actually try to fix it by looking to see if there's a replacement for that nozzle in stock. This is great. We have expert knowledge from
So just
Shahar.
a quick
Yeah.
question here, Joe, because I've been in the factories with you on this one, but this is, pretty new technology, and like, the factory can be noisy, and Shahar's got a lot of busy stuff to do here. But what I think you just showed is, Shahar needed to kind of come and maybe label and diagnose the issue. And I guess, I don't know, you've like, he's leaning over his computer? Does he have to get super close? Does the noise like kind of what's that experience like for him?
Nope. So this is definitely something we've tested and worked on and refined over and over. And there's many different ways that he can leave the comment. So if he has a microphone just on a desktop, he can do that. There's also mobile screen, so he can do it with his phone. He can do it on a tablet if he's allowed access to that. And the system will pick up very, very clearly on his voice. And we've gotten our transcription speed, performance, and accuracy very high, even in these scenarios where there's other people talking or there's machines running at a high decibel. So really, we've tried to make it as seamless as possible and as easy as possible for someone who's on the floor to just give us that snippet, give us that gem, and you'll see he did leave a little gem for us on how to get that line back up and running as quick as possible.
He's in the middle of his workday. He's not disrupted. You've saved him time compared to the labeling he'd have to do. And then, yeah, okay. And he's got some gems.
Exactly. So Jesse, if you let us run the video again and then maybe skip ahead just a few
Because
seconds there.
that's
Yeah,
critical, as I think the people watching know, is if you are the expert, you understand that you'd like to share your knowledge, but you've got your own job to do, and you can't be given another job at the same time. I want you to just download your knowledge all the time to these people and these systems, so that they don't depend on it. Doesn't feel good. You don't have the time for it. Your job got even harder. So I think that's really important how you highlighted here. So it's saving him time in the middle of his flow, but he's also able to share things.
exactly. So we don't ask him to come in and look at a huge list of all of his categories and reasons. Because he left that comment, now the system can automatically label that. You can see here that there's an insight, right? The system's saying, oh, I see this comment, I see the machine, or see the machine data. It's probably the machine category, and it's probably the reason of placement issues. So now, because he was quickly able to leave that comment, we gotta get a 2-for-1. We get that gem of that knowledge. We also get the label on the downtime so that his OEE gets calculated accurately, so that time is labeled accurately as to what went on. And again, like you said, completely seamless, as quick and easy as possible as we can possibly make it. Okay, so let's skip back over now. I'm gonna kind of reset the scene. We're now a couple days even further into the future. And if you see, it looks like I'm on the line again. I'm back to being my junior process engineer. I'm in Detroit, and maybe again trying to keep this line up and running as efficiently as possible. I get another ticket. The thing's down again. Looks like it's a very similar ticket on the same line. And I'm like, man, okay, I guess maybe what I did didn't work. Either way, I come into the ticket here. I look at the summary. It's giving the very similar summary from what I had before, but this time it's on a different machine. Still, it's a high attrition rate. Something's going on with placements. Mispicks are high, and it's pointing me to a nozzle. Nozzle 3 has 9,000 mispicks. So again, same probable root cause. There's a feeder and nozzle issue on nozzle 3. Now, if I come down to next steps, you can see that looks like there's an extra step there that's been added. So step 1, disable nozzle 3 and NXT 2-8 configuration settings. And this says it's user suggested. So right away, again, my last ticket that I got on this was about 5 days ago. And in that interim, we've gotten a little piece of knowledge, a gem of knowledge that the Arch's AI system has picked up on, repurposed now. So process engineer in the future can hopefully resolve this issue quickly. So now I'm on my line. I'm like, okay, let's try this. I'll try and just disable the nozzle, see if it gets things running as quick as possible. So I've got out of my ticket. I do it. Look at that. Okay. Let's say the line is running again. Step one worked. At least I can avoid a major downtime like I had last time. I have this little step that guided me towards the right thing to do. And then I can run through the rest of these steps that are being suggested by the system. I can, go out and look for a new replacement. I can, if I need to, I can run calibration and things like that. But I have this backup that I got from my buddy Shahar, who I might not even know, don't even know he exists. And now I can come in, I can resolve my ticket. I can type in, I tried step one and it worked. And here again, the system is going to see that the resolution worked, and then it'll strengthen even further that disabling the nozzle is a solution that the system can use long term to suggest to users when this issue pops up. So, Jesse, you can pause there. Yeah, I can give a rundown of what just happened, but Andrew, if you have questions or things to zoom in on, let's do it.
No, I think that was great. That was an excellent demo. Thank you, Joe.
Awesome. Yeah.
All right, let's pull down the video and pull back here to our slides. So yeah, let's break that down a bit together. What just happened there behind the scenes, especially for any of the technology folks that are watching who are thinking like, how do you implement this? What's actually required to give guidance and translate, knowledge from operators in one plant to another? So just like if you've been watching the other webinars and sharings that we do, the overall structure of these AI agents that make this possible is quite common actually to the last example we gave of how you figure out a downtime that's going on and automate the labeling system. So there's an event first, the red arrow here. There's condition based and predictive monitoring. And this starts a process that kind of wakes up the AI, so to speak. Like I know that there's a real downtime happening. I know in this case, I know there's a real attrition scrap event, which is anomalous and it should be addressed, right? Or even a full downtime. The line, more advanced line, already has the programming to go ahead and freeze, stop the line to stop attrition from getting too high. That wakes up the AI expert agent, which goes and gets as much available information as it can. So in Joe's first example, there wasn't any voice of the operator expert knowledge that was relevant to be pulled into the root cause and guidance. So it was going to the voice of the process, going into machines, data, going into dashboards. And Joe mentioned it could have been dashboards built by Arch. It could have been the dashboards of the machine itself. It pulls that information into a synthesized document, which can now talk to these advanced AI models, including these new class of large language models, and they can automate the root cause and guidance. The root cause is likely, it was nozzle 6 or something on a particular machine. Try 1, 2, 3, and then resolve. And the junior engineer confirmed, I did the steps. I think it's going to be fixed. Let's see what the attrition's like, right? And then there was a second example in Tel Aviv where an experienced operator is just getting it done and solving it, knows that this nozzle needs to be replaced, and puts a skip operation in. And this feedback that they give on the downtime of what they did was interesting. And so the next time back in Detroit, the AI model queries, it has more interesting data. And so it builds that root cause and guidance from a larger set of information that's been marked as useful in this organization. So that's what was happening behind the scenes that makes this possible, this powerful combination of the digital twin being connected to the machines, MES, the live data that tells you there really are true problems happening, and then being able to collect feedback and voice of the operator, interesting information over time that further strengthens the quality of these recommendations. In closing, let's go through a real use case as well. In addition to the one that we saw in the demo here, that's caused significant value. And this is an increase in throughput via AI-powered knowledge sharing. So a manufacturer had multiple production lines in Mexico that were running an average of about 60 units per hour on a pretty high value end product. This was in the automotive space. The data suggested that these lines should be achieving 80 units per hour. They were running a similar product to what was running in different parts in the company in Europe and China. Back to the very beginning, this is increasingly common in this regionalized world, that we're not just building totally different products, we're building really similar things in different parts of the world. We're not sharing the land, the building, the people, but it would be really great if we could share process knowledge. How do organizations share process knowledge today? They put their experts on airplanes and they fly them around the world many times. So that's what was happening here. There were top experienced experts in both a European plant and in a Chinese plant, where they tried to have them visit every 6 months to get this operation running better on these key units and get them to higher throughput so that they could make the key numbers with the capital investment that they had made. Right? Well, as you can imagine, this sometimes works when there's like one key change you need to do every 6 months. But when there's a lot of small things all the time, this kind of tactical expert operator knowledge, oh, you could skip nozzle and keep going, or here's where you need to look, especially with the increasing amount of changeovers and new things that are happening, that's not resulting in the net high performance that you need. It's just not enough to fly experts on a plane every 6 months. And that was absolutely the case here. So this manufacturer worked with Arch. We got our system in place, and we now were able to set up real-time triggering of problems that were happening and real-time triggering of these tickets, where we had the opportunity to transfer knowledge better. Now, this particular manufacturer, this was happened in the past. So the generative AI that you just saw today wasn't working quite as seamlessly. We were still working as people to do it, but nonetheless, we were able to see these tickets that were appearing in real time. We were able to diagnose the root causes of issues. In this case, it was an industrial engineering challenge. Why are they not having the throughput that they're having? And through the use of AI and learning from the experts in other plants, identify some of the resolutions that they were doing to do it. In this case, specifically around test time reduction. Like there are specific test machines on this line. And what are the specific test machines? What are the specific recipes that have higher test time than they really need for the coverage? Those are actually reducible. And if you bring those down, you maintain the quality and you get much higher throughput through your line. Right? People make changes at some point. Maybe they held over from the old. Maybe they didn't make an expert test plan. Maybe they made the test plan longer at somebody's push and then later failed to go back and optimize it. That happens with nozzle skips as well. Someone puts in a nozzle skip and then later doesn't go back and remove it, and it's still in the programming when it's no longer needed, right? So that was what was happening here, especially around a test time plan. And so when we were able to identify the root cause of issue automatically with technology, transfer knowledge in real time from how experts were solving similar problems in Europe and China, the site was able to increase throughput and significantly and keep it running. It was more than $5 million annual savings from higher throughput achieved by the team, and it reduced the need on expert engineers to jump on planes and travel all the time. They could work in their plant, do excellent work. Excellence anywhere can become excellence everywhere. Do excellence in their own plant, share knowledge, and benefit the global corporation that they were part of. Awesome. Thank you all so much for joining this webinar. We had a really powerful one recently on automated downtime labeling. If you missed that one, you should go back and check it out. It is available recorded. We are going to be at the Apex conference soon, which is an electronics manufacturing conference, talking about Gen AI in the factory, reinventing work for electronics manufacturing. We're going to have a live presentation there where we're going to be talking about use cases and particularly how they pair with MESs and machines. And stay in touch with us for following webinars and topics on this.